Here is an interesting puzzle that comes to us from Mr. Ajit Atle. He is a mechanical engineer from the prestigious IIT Bombay. Thank you, Mr. Atle. This is a very interesting problem. The problem is there is a 3, 4, 5 right triangle. In it, there are 4 identical circles packed like this. They are tangential to the base, tangential to the height, and tangential to the hypotenuse as shown. And we are supposed to find the radius of a typical circle here. Okay. So if you want to do this problem on your own, you can pause the video. Otherwise, we'll go ahead and solve it here. Okay. So let us make some room for solution. So we'll just shift these things. We'll make a copy of this triangle and the 4 circles at some convenient distance, say over here. And then to solve, we are going to focus on just one circle. See, the problem is if there was just one single circle, this would have been an easy problem. But with 4 circles, we don't have any standard formulae to apply. So we are going to go to some familiar scene. For that, I'll just move this line here, this side, until it becomes tangential to those 2 circles. Then I'll move even this vertical side and make it tangential here. Then we are going to trim these sides. So only a triangle is left behind that is tightly fitting around this circle. See, it was already tangential to this hypotenuse. We have made it now tangential to the other 2 sides. So now we are looking at a right triangle, which is going to be similar because we moved everything parallel to itself. So no change of angles. So we still have a triangle that is similar to the original, and we are talking about its incircle now. Moreover, we are going to think of this triangle as if it is dimension in some other system of units. So we will say its dimensions are still 3, 4, 5. Only the units are different. So something like, if you took some triangle in inches and shrink it, but now it has the same dimensions in centimeters. So something like that has happened. Of course, I'm not saying these are inches and centimeters, but some other system of units where the units still remain 3, 4, and 5. And now we are going to find out what is the radius of the incircle. So this radius we are going to find. All dimensions in the old system will show in blue, while those in the new system, okay, of units will show them in red. So let us now figure out what is the radius of the incircle. For that, we are going to start with the area of this entire triangle, which is half base into height. So 3 into 4 divided by 2, that gives us 6. Then we'll calculate the same area, but this time we'll be taking it as the sum of these 3 triangles, okay? Yellow, blue, and green. So then the area can be expressed as half of this base 4 into the altitude, that is r, then half of base 3 into this altitude r, and half of this base 5 into altitude I. So this half r can be taken out common from all the 3 terms, giving us half r into 3 plus 4 plus 5, which amounts to 6r. Now this area 6r is equal to this area 6. So we can equate the two and get the value of incircle radius as 1. So now that we have figured out this incircle radius, or the radius of this little circle, to be 1 in our new units, we'll start reconstructing over here so as to go back to the original triangle. Okay. So for that, I'm going to take this triangle around this circle, and I'll just copy it and fit it around the other 2 circles. Now some of these dimensions we already know. Okay, this is 4 units in the red dimensions, so I'll show that. We have figured out the radius of these circles. It is 1, so this diameter will be 2 over here. And to reconstruct our original triangle, we need some triangular piece here. So I will start with a 3, 4, 5 triangle like this, and I realize it is rather too big, so I'm going to scale it. Okay, I'm going to scale this triangle about this point until this side, which is 3 now, should shrink and become 2, right? 2 is the diameter of this circle. So we have made this side become 2/3. So even this side, which was 4, will become 2/3. 2/3 of 4 is 8 upon 3. So I'll show that dimension here. So overall, this base will now become 2 plus 4 plus 8 by 3, which is 26/3. Okay. We can even reconstruct the original triangle here by extending these sides. It's not necessary, but can be done. So now we have two identical figures. Okay. Only thing is they are dimensioned in different set of units. So in this set of units, in the red units, the base is 26/3 and the radius is 1. So we will say if the base is 4, what should be the radius? It's going to be a linear variation. So we can put it systematically like this. So we'll write the base and radius in the new units as we have found 26/3 and 1, and we'll figure it out in the old units. The base is 4, how much should be the radius? Okay, so these are the values. So we'll just calculate this 4 into 1 divided by 26/3, which will give us 12/26, which is 6 upon 13. So that's the radius of this little circle, or rather all of these circles. And lastly, before we sign off, a little bit about the ways of solving problems. Over here, is this the only way of solving this problem? Of course not. There must be dozens of other ways one can reach the solution. Only among those, some are going to be more fun, while the others are going to be just tedious, laborious work. So using coordinates or using trigonometry will always give you a solution, but that's not the most exciting way of solving it. So if you are into solutions that are fun, that are exciting, then you are going to like this channel. So in that case, please subscribe and hit the bell icon. So thank you for watching and take care.